Good morning, everyone. I am Sunil Kumar Vishwakarma, Assistant Professor, Department of Computer Science and Engineering, School of Engineering, Babu Banarsi Das University, Lucknow. Today, in this subject, Computer Networks, I am going to discuss the concepts of FDDI, that is Fiber Distributed Data Interface. Now, what is FDDI? FDDI, Fiber Distributed Data Interface, is a set of ANSI and ISO standards for data transmission on fiber optic lines in a local area network that can extend in range up to 200 kilometers or 124 miles. Okay, so what is ANSI? ANSI is American National Standard Institute, and ISO means International Standard Organization. So these both organizations developed a standard for data transmission on fiber optic lines, and this is especially for local area network, and the range of this network can extend up to 200 kilometers. Now the FDDI protocol is based on the token ring protocol. Token ring and token bus we have discussed in the previous video. In addition to being large geographically, an FDDI local area network can support thousands of users. So the number of users is very large, and FDDI is frequently used on the backbone for a wide area network, and it can be used as a backbone for wide area network. So for this, an FDDI network contains two token rings, one for possible backup in case the primary ring fails. So the ring topology, previously we have considered only one ring, but here in case of FDDI network there are two token rings, and one is for backup and another is used if one of the ring is failed or fails. Another backup ring is used for the communication purpose. The primary ring offers up to 100 Mbps, 100 megabits per second capacity. If the secondary ring is not needed for backup, it can also carry data, extending capacity to 200 megabits per second. So the single ring can extend the maximum distance. A dual ring can extend 100 kilometers, that is 62 miles. So this is the beauty of fiber distributed data interface. Okay. Now the features of FDDI. FDDI uses optical fiber cable as its physical medium. We have discussed various type of wired mediums, and out of that FDDI outperforms. It has many advantages over the twisted pair cables, fiber coaxial cables, shielded and unshielded twisted pair cables. So FDDI uses optical fiber cable as its physical medium. And another point is it operates in the physical and medium access control layer of the open system interconnection network model. In OSI model, there are 7 layers, and the layer 2, we call it data link layer. That data link layer is divided into 2 sub layers, that is logical link control and MAC sub layer. And this FDDI operates in the physical and medium access control layer of the OSI model. Now the third point is it operates high data rate of 100 Mbps, 100 megabits per second, and can support thousands of users. And it is used in the local area networks up to 200 kilometers for long distance voice and multimedia communication. Voice communication and multimedia communication. Voice communication is clear, but what about multimedia? Multimedia communication means more than one medium, that is text, audio, video, image, graphics, for the communication of these type of things. Now the next point is it uses ring based token passing mechanism and is derived from IEEE 802.4 token bus standard. It contains two token rings, a primary ring for data and token transmission and a secondary ring that provides backup if the primary ring fails. So in FDDI there are two token rings. Now the next point is FDDI technology can also be used as a backbone for a wide area network. FDDI technology can be used as a backbone for wide area network. This is the diagram of FDDI, fiber distributed data interface. There are workstations, servers, hubs, network connecting device as network connecting device, workstations, and there are tree or bus networks connected to the FDDI. There is primary ring and another is secondary ring. The outer ring is shown as a primary ring and the inner line represents the secondary ring. This is the fiber distributed data interface diagram. Now the frame format. The frame format of FDDI is similar to that of token bus as shown in the following diagram. This diagram shows the FDDI frame format. There are several fields. Preamble field is taking 1 byte for storing information. Start delimiter 1 byte. Frame control 1 byte. For the destination address 2 to 6 bytes are used. For the source address 2 to 6 bytes are used. Payload field is of variable length. There is no fixed length for this. And for the checksum field there are 4 bytes fixed, and for the end delimiter 1 byte is required. So this is how the frame is represented in the FDDI, fiber distributed data interface. Now these are the fields of FDDI. Preamble field takes 1 byte and it is used for the synchronization. Now the start delimiter. This field uses 1 byte that marks the beginning of the frame, because every frame has its beginning and its end also. So 1 byte of storage is required for marking the beginning of the frame. Now the next is frame control. 1 byte that specifies whether this is a data frame or control frame. So 1 byte is required for specifying whether this is a data frame or control frame, because there are two types of frames can be used, data frame or control frame. Now the destination address. As a destination address, storage requirement is 2 to 6 bytes that specifies address of destination station or destination computer or destination node. Now the source address is 2 to 6 bytes that specifies address of source station. Now the payload field, a variable length field that carries the data from the network layer. So payload field is used for the it is a type of field that carries the data from the network layer. So because there are 7 layers in the OSI model and the network layer is third layer of the OSI model. The second last field is checksum. Checksum field is used for the error detection in the data. is there any error in the data? With the help of this technique, error is detected. And for this, 4 bytes frame check sequence is used for the error detection. Now the end delimiter. 1 byte storage required that marks the end of the frame. From where the frame has started, for that start delimiter is used, and for the end of the frame, end delimiter field is used. Okay. Now the advantages of FDDI. There are some advantages and disadvantages of FDDI. In advantages, first point is fiber optic cable transmits signals over more noteworthy separations of approximately 200 kilometers. So in FDDI, we are using fiber optic cables, and that transmits signals over 200 kilometers. And it is conceivable to supply the need to the workstations associated within the chain. Consequently, based on the prerequisite, a few stations are bypassed to supply speedier benefit to the rest. It depends on the situation that which type of stations will be bypassed to supply the speedier benefit to the rest of the stations. Now the third advantage is FDDI implements different tokens to make strides organize speed. It offers a higher transmission capacity, that is up to 250 gigabits per second. Thus, it can handle information rates up to 100 megabits per second. It offers stall security because it is troublesome to spy on the fiber optic link. Fiber optic cables does not break as effectively as other sort of cables. So these are the advantages of FDDI, and now the disadvantages of FDDI. FDDI is complex. It is not simple. Thus, establishment and support require incredible bargain of expertise. Okay, so for establishment and support is comparatively difficult. So we can say that FDDI is complex. Now the second disadvantage is FDDI is expensive. Typically, since fiber optic cable connectors and concentrators are exceptionally costly. So due to this, FDDI, fiber distributed data interface, is expensive. So these are two advantages of FDDI. This is the representation of FDDI. There are 4 nodes, node 1, 2, 3 and 4, and here 2 rings are shown in the figure. One is primary and another is secondary. Ring 1, primary ring, carries the data, and secondary ring is used for the backup. If primary ring fails, the backup ring or secondary ring takes the control. This is the FDDI example, how the data is transmitted in the FDDI. There are 3 rounds in this example: first round, second round and third round. There are different arrival time and synchronization bits. It is shown in this example. This is the 4th round and 5th round is shown, and there is different arrival times for the different rounds. FDDI encoding. In every data transmission, some encoding technique is used. Now here is FDDI encoding. Here it is represented the data in the form of discrete signals 0, 1. Now the FDDI layers, fiber distributed data interface layers, and here in this figure there are two layers, physical layer and the data link layer, and collectively it is represented by the station management. So in physical layer there are two things, physical medium dependent PMD and physical PHY. In the data link layer there is medium access control sublayer and the logical link control sublayer. Okay, so these are the FDDI layers. So for FDDI, we can say that FDDI was considered an attractive campus backbone network technology in the early to mid 1990s, since existing Ethernet networks only offered 10 Mbit per second data rates, and the token ring network only offered 4 megabits per second or 16 megabits per second rates. Thus, it was a relatively high speed choice of that era. But by 1994, vendors included Cisco System, National Semiconductor Network Peripherals, Sysconnect. These used the FDDI. Now, these are the FDDI frames, and for the token there are three fields: SD, FC and ED. Start delimiter flag, frame control that represents the frame type, and ED represents the end delimiter. And for the token these three fields are required, and for the data field there are four fields are required: DSAP, SSAP, control field and information field. So these fields we have already discussed. These are the FDDI rings. One is primary ring and the dotted line represents the secondary ring. One token is passing clockwise in one ring, and in another ring it is passing anti-clockwise. So both rings have different directions for the movement of the data. If in this figure it is shown the situation when primary ring fails, failure of the primary ring. So if the primary ring fails, secondary ring works efficiently in the case of failure. These are the FDDI nodes. And there is dual ring. So FDDI offers DAS. What do you mean by DAS here? Dual attached station. So FDDI offers both a dual attached station, DAS, counter rotating token ring topology, and a single attached station, SAS. So here in this figure, DAS and SAS both are represented. DAS represents the dual attached station and SAS represents the single attached station. Okay. Thank you so much.